Can you give me 5 minutes? In 5 minutes, I can make you an expert on water pollution. All right, let's jump right in. When you see polluted water, the first thing you want to know is, where did all that gunk come from? Well, it's kind of like playing detective, and there are two main types of suspects. So, on one hand, you have what's called point source pollution. Think of it like this: it's a single pipe pouring waste into a river. You can literally point your finger at it, it's obvious. But then you have non point source pollution. And this one is way trickier. It's not one pipe, it's more like runoff from an entire city or a huge farm field. It's coming from everywhere at once. So, give you a picture of point source pollution, think about a discharge pipe from a massive factory farm, or the emissions from a single power plant, or, a huge disastrous oil spill. The damage can be absolutely massive, but in every case, we know exactly where it came from. The culprit is clear. Now, non-point sources, that's a whole other story. Just imagine it's raining in a big city. That water washes over streets, picking up motor oil from cars, fertilizer from people's lawns, salt from the roads, and it all flows into our waterways. It's a nasty cocktail, and you can't pin the blame on any single source. Okay, so let's move on. And for this part, forget about all the complex chemicals for a minute. Let's talk about something really simple: dirt. What happens when our beautiful rivers start to look like chocolate milk? Well, that dirt is called sediment. It's really just tiny pieces of rock, soil, and even leaves and twigs. And a little bit is totally natural. But when you get massive amounts of it washing in from places like construction sites, it becomes a huge problem, a major pollutant. And check this out, it kicks off a whole chain reaction. First, all that sediment makes the water super cloudy, right? That blocks the sunlight from reaching the plants at the bottom. So no sunlight, no photosynthesis, the plants die. Then the fish and other critters that rely on those plants for food and oxygen are in big trouble. The sediment can even clog their gills. It basically chokes the entire ecosystem from the bottom up. So sediment is a problem you can see. But some of the worst kinds of pollution are completely invisible. They create these vast, eerie, dead zones right under the surface. Here's the question to think about. We all know fertilizer makes plants on land grow like crazy. But what happens when all that leftover fertilizer from farms washes into the ocean? Well, you get way, way too much of a good thing. It's basically a recipe for an underwater desert. Those extra nutrients, the nitrates and phosphates, cause this massive, explosive growth of algae. It's called an algae bloom. But then all that algae dies and sinks, and the bacteria that decompose it, they suck up all the oxygen in the water. The result is a dead zone, an area with so little oxygen that fish and crabs literally can't breathe. We've talked about what happens to the water, but what about all the animals living in it? You see, some pollutants don't just disappear, they build up, and they get more and more dangerous as they travel up the food chain. There's a name for this process: bioaccumulation. It's a fancy word, but the idea is simple. A toxin, like mercury, gets into an animal's body and it just stays there. It builds up in their tissues because they can't get rid of it. And this is where it gets really, really concerning. Okay, let's use mercury as the perfect example. It gets into the water from things like coal-fired power plants. Now, a little fish might absorb just a tiny bit, but then a bigger fish comes along and eats, say, 100 of those little fish. Well, it now has 100 times the mercury. Then an even bigger fish eats that fish. By the time you get to the top of the food chain, think sharks or even us, that toxin is super concentrated. And this, right here, is why it matters so much to us personally. It's the reason why the FDA has advisories warning pregnant women to avoid eating fish like swordfish or king mackerel. That concentrated mercury is especially dangerous for a developing baby's brain and nervous system. It's a direct line from pollution to our own health. For our last stop, let's look at what happens when an entire ecosystem gets pushed to the brink of collapse by pollution and rising temperatures. I'm talking about coral reefs. So you have to understand that coral reefs are built on this incredible partnership. The coral itself is actually an animal, and living inside it is this tiny algae. They're like the perfect roommates. The coral gives the algae a safe place to live, and in return, the algae makes food for the coral and gives it those amazing, vibrant colors. But here's the catch. Those little algae are super sensitive to temperature. So what happens when our oceans get warmer because of climate change? The whole relationship just breaks down. The coral gets stressed out by the heat, and it literally kicks its roommate out. It expels the very algae that was keeping it alive. And without that algae, the coral loses its main food source and all of its color. It turns this ghostly, bone-white color. That's coral bleaching. Now, the coral isn't dead yet, but it's starving and incredibly vulnerable. It's one of the most visible and heartbreaking signs of our planet's health. And there you have it. That wraps up our crash course. And that's your 5-minute expert take on water pollution. From the blame game of pollutants to cloudy rivers, underwater deserts, and the collapse of our vibrant coral reefs. Thanks for giving me 5. Make sure you like, subscribe, and comment.